Hi guys, I'm Alex and welcome to Dantium 1. Today we're going to be talking about redox reactions. However, first we need to know what is meant by oxidation number. There are 5 main rules regarding this.
An oxidation number is a measure of the number of electrons that an atom uses to bond with atoms of another element.
The first rule is that all elements have an oxidation number of 0. For example, magnesium 0, lithium 0.
Rule number 2 is that when oxygen is in a compound, usually it has an oxidation number of -2. For example, water, -2, sodium hydroxide, -2, and aluminium oxide, -2. However, in a peroxide, the oxidation number is -1. For example, hydrogen peroxide.
So rule number 3 is that hydrogen, when combined in a compound, has got an oxidation number of +1. Here we can see sodium hydroxide. We know that oxygen's -2, the hydrogen will be +1. In methane, let's say the oxidation number of hydrogen is +1. In water, we know that the oxidation number of oxygen is -2, the hydrogen will be +1. The exception is when you've got something like a group 1 metal bonded directly to hydrogen, like sodium hydride. And if it says hydride, the oxidation number is -1 rather than +1.
The oxidation number of a simple ion is equal to the charge on its ion. A naff example of this is sodium fluoride. Sodium has an oxidation number of +1, fluorine has an oxidation number of -1. Another example is this one. The aluminium has an oxidation number of +3, the oxygen has an oxidation number of -2. And that is rule number 4.
Oh, hello there. The 5th rule is that the oxidation number of combined fluorine is -1. This is a boron example of boron trifluoride, or BF3. It has +3 on the boron, -1 on the fluorine.
The following is an example of a redox reaction. We're going to see a 1:1 mole ratio of zinc and sulphur. This is the reaction between zinc and sulphur.
Tell us about the oxidation states, Will.
Well, zinc has got an oxidation state of 0 because it's an element, and sulphur's got an oxidation state of 0 because it is also an element. However, when they combined form zinc sulphide.
So we say the oxidation state with respect to zinc is +2 and with respect to sulphur is -2. There seems to be a bit of a delay. At any moment it could go whoomph.
We hope.
We hope, indeed.
Oh, it's sparky.
It's going to go any second.
Oh, and it's very red.
Oh, it's glowing.
Guys, so now we're going to be doing another redox reaction, and this is the displacement reaction between magnesium and copper oxide. So obviously magnesium is an element, so it's going to have an oxidation number of 0, whereas copper oxide, as we know from our previous rules, the oxygen is going to have an oxidation number of -2, hence the copper is going to have an oxidation number of +2.
The activation energy is pretty high. Strong bonds between the copper and the oxygen.
I like it.
I've got a little fuse, here it goes.
Oh! Alright guys, me again. So I would now like to explain to you the difference between oxidation and reduction. So we have here a nice little mnemonic and also a nice little picture to go with it of an oil rig. What does oil rig mean? Maybe you're wondering. So we have oxidation is loss, reduction is gain. Now, oil rig. Now, what is it that is being transferred in these reactions? And the answer is electrons. So, when it says loss, we can replace this to of electrons. When it says gain, we can put here of electrons. Alright guys, so if we can see the changes that result across the reaction, we can see that zinc goes from 0 to +2. It is hence losing 2 electrons. So as you can see from the oil rig, oxidation is lost, therefore it is being oxidized. And equally we can look at the sulphur. We can see that sulphur is going from 0 to -2. It is hence gaining 2 electrons, and as a result it is being reduced. Now, the definition of a redox reaction is a reaction in which both oxidation and reduction simultaneously occur. So, we can see that oxidation is happening, yes. Reduction is happening, yes. Therefore, this reaction is a redox reaction. We can equally look at our second example here. We have magnesium, which, as it's an element, oxidation number. Oh, I'll switch back to my previous pen to have a bit of uniformity there. So, if we look at magnesium, it's an element, therefore it is 0. If we look at copper oxide, we know oxygen is going to be -2, therefore copper is going to be +2. And then if we look over here, this is going to have switched, so this will be +2, and now this stays -2. And the copper will have changed to be 0 because it is now an element. So again, we can see how these change across the reaction. So we can see that magnesium is going from 0 to 2+. It is hence losing 2 electrons. Therefore, from oil ring, we can see that oxidation is lost, so it is being oxidized. And as we've seen in the previous reaction, we know that copper is going from 2+ to 0. It is therefore gaining 2 electrons. It's going to be the opposite. It is going to be reduced. And as described before, we can see that both oxidation and reduction are happening at the same time. Therefore, this is a redox reaction as with the previous example.
Dictionary definition of redox. Rusty cattle. Red ox. I've got another math one. You ready? Sodium reacted with fluorine. So sodium says, oh man, I've lost my electron in this reaction. The fluorine says, are you sure? Thinking, yes, I've got his electron. Sodium says, yes, I'm positive.
Oh, hi, Will.
Hey, knock knock.
Who's that?
Hydrogen.
Hydrogen who?
No, hydrogen has an oxidation state of +1.
But
Thank you for watching Down to 1, guys. Merry Christmas.